Hey guys, we're going to do stats chapter 3 and 4. Okay, so as we review this, the first question says the following pair of variables would be expected to have a negative relationship. So on our cheat sheet, we look at here, it says negative means as x goes up, right? As x goes up, y goes down. So we're looking for an answer that matches that, right? So we see that choice D. So again, just don't select your answer. You got to show some kind of a notes. So as miles driven goes up, the more miles I go, the amount of gas remaining must go down. So I don't have any gas left. If I started with a 20-gallon tank and I keep driving and driving and driving, I'm going to go down to 1 gallon and now I need to get gas. Okay, that's a negative relationship. Number 2, we look at our formulas here, right? And we want to use these formulas to answer this question similar to the example we have here. Right, so I'm just going to take a quick picture of that and plop it down here because those are the formulas I need, right? So I need these formulas to answer this question. Okay. Sorry, there's the bell. So let's see. Okay, so I need to get this, right? These are my choices. And I'm going to plug in each one of these. So let's see. In order to get B naught, I need B1. So I've got to do this one first. Right? Okay, so B1 is R. So I have that, 0.6408. S sub X, 0.5. And S sub Y over S sub X. And now I'm just going to crunch some numbers. Nice. And so I get B1 is 0.267. Now I know what B1 is. And so now I can find B naught. So I'll just use kind of a different color just to kind of keep them straight. So Y bar, so the average Y value is 2.7. And we know this is 0.267. And the average X value is 3.8. So we just do a little crunching here. All right, so B naught is 1.6854. Now we're going to stick each of these in their spots, right? So to build this equation, the expected Y value would be 1.69. I'm just kind of rounding here, and then 0.267x. 0.267x, 0.267x, so 1.69, there we go. C is our choice. Nice work. Now let's look at 3. Meg has a set of bivariate numerical data with a correlation factor of 0.83. Elise has a data set with a negative correlation, but the same amount. So what does this mean? So an R value of 0.83 would essentially say that the dots, or if it's negative, the dots are fairly close to the line of best fit, right? It's a fairly strong relationship. And an R value of a positive 8.3 would be that the closeness of the dots are exactly the same. The only difference is that one's a positive relationship, one's a negative relationship. What can you conclude about these two sets of data? So we could conclude that it's strong. Well, I'd say relatively strong. So let's keep reading. In Meg's data, 83%. No, that's the R squared value. Or actually, this is bad wording. In Elise's data, 83% of the variability. No, that's R squared script. Meg's data is more linear. You couldn't conclude that. So this could actually be, without looking at this, you could have an R value of positive 83, but it could make a U-shaped. You know, that's not just tending. Without looking at this scatter plot, I can't really conclude something about the data set. All I can conclude is mathematically the dots are the same closeness to the line. That's all I can actually conclude. So in fact, it might not, one of them or both of them might not be linear. We can't just look at R to decide whether or not something is linear. We have to look at the scatter plot. Okay. Question number 4. Based on the scatter plot data, which of the following is true? Okay. So it says, if this was my data, it looks like A is an outlier. I definitely can't go about saying that A is not an outlier. Okay. And a potential influential point. So we can actually see here that if we imagine that A isn't there, then this line of best fit would probably be there. So A in and of itself is changing the slope, right? This is the y-intercept without A, and this is the line of best fit with A. So it's influencing your y-intercept. It's influencing your slope. So this is definitely a potentially influential point, point A. So I'm going to pick A. Choice A. And how do you show your work on this problem? Again, I would show the line of best fit, least squared regression line with A, and then show it without A, with steeper. Okay. 5. Just take a look at that for a minute. 5 tells us we have to read the output. So I told you that just kind of ignore this section for a while, right? And this is A and this is B. So we have y hat equals A plus bx. So our predicted y value is negative 0.868 plus negative 1.6914x. And it doesn't tell me what it is, but if they said time there, I knew x was time. All right, now what is this already? What do I know? This is telling me the slope is negative. So this is also telling me r is negative, but when I square a negative, I get a positive. So I know the slope is negative and I know r is negative. So when I take the square root of 0.80, that's r squared, but when I take the square root, of 0.8, I get negative 0.8, right? I don't get a negative, but again, I have to make r negative because I know the slope's negative. So there's got to be a negative relationship happening here. All right, looking at my choices, it says, since r is, no, I don't like that one, right? Since r is this, the linear relationship is linear, strong, and positive. Yeah, so it says which one is false? So we know that one is false because we know r is negative because here that is our slope. Cool? And it looks like the rest of this is correct. So if we look here, that's the formula I made there, right? The intercept is A, and that's that number there. So all these other ones. And how do we interpret r squared? We interpret it by saying 80% of the variability of y is explained by the least squared regression line on x. Okay, let's go to 6. Which of the following scatter plots could have been created? So again, we can tilt our paper. Essentially, it's saying we remember that at the beginning of our data set, we're below the line of best fit, and at the end, we're below the line of best fit. So let's see which ones that would be. This is the line of best fit. Let's kind of draw those in. And we zoom in, we notice that here and here I'm below the line of best fit, and here I'm above it. So I'm going to pick B. That's got to be my answer. Right? And it's because it's following this same pattern. Right? Why is it not C or D? Notice here that it is above the line of best fit at the beginning and ending in these two. Okay? So that's how I come to B. 7. Two variables are exponentially related. The least squared regression line can be transformed by this formula. What is the predicted value? Okay, so this comes right out of our cheat sheet too. So the natural log. And we're really just being asked to plug this in. So this is kind of an algebra question. What is the predicted value? So they're asking you to solve for y hat. They're not asking you to solve for the natural log of y hat. So I will have to do something to the number before I get my final answer. So they're really just asking you to plug this in. So when we plug this in, let's see what we get. So I get 16.83 times take away 0.041. Okay, so I get the natural log of y hat is 0.017905. All right. Hopefully I typed all that in right. I'm going to type it in one more time. 16.83. Okay. Now, I need to solve for that, and I got to get if I'm going to solve for y hat, I have to get it by itself on one side. So the inverse of natural log is e to the power of. So if I take e to the power of the natural log of y hat, I get y hat. And if I take e to the power of 0.017905, let's see what I get. This should be right off of my calculator, right? And I get 1.018. So now I'm going to be looking for my answer, B, 1.018. Nice work, guys. Question number 8. In the early human ancestors, they were similar in shape to most large primates. Data below shows average male hind limb, forelimb lengths for different species. Relatively short hind limbs are thought to represent an evolutionary specialization for vertical climbing. All right, so we've got our computer output. Here it is, right? We've been told to kind of ignore this side of the table for now, right? And we know that this is A and this is B and this is X, right? So y hat equals A plus BX. And A is this. And B is that. The scatter plot is shown below. Okay, so with this information, I guess we're going to answer a handful of questions on the next page. Which of the following is a correct interpretation of the slope? Okay, and so that's in our notes too. We have to interpret slope. So let's see what the slope is. So the slope is the number in front of the x, and we know that's that. So 0.2974. Oh, and looky here. They actually built this equation for us. 0.2974. So we said in our notes, 0.2974. And what is slope? But it's the change in y over the change in x. So what is it? Well, whatever y is, it's 0.2974 of y over whenever I change one of the x. So let's just look again. What's x and what's y? Hind leg and hind 4. So for each additional one hind limb, for an additional hind limb, so I like that, for an additional forelimb, for an additional hind limb, so I'm liking the B and C, it will increase, so that was a positive number. I like that. The predicted length by this number. Okay, so we found our answer. Our answer has to be C. And again, we know what little bit of work we can show. We might rewrite this as well. So for question 9, using the same information, which of the following would be the correct interpretation of the intercept? So that would be this number. So what does that mean? Well, that's when, does it make sense to set x to 0? Well, what is x? It's when there's a forelimb, and I'm thinking it doesn't make sense necessarily. Why would anyone, you wouldn't be alive if you had absolutely no forelimb. So I'm going to pick E. None of these are correct. These are trying to talk about slope. None of them are trying to talk about when forelimb is 0. Okay? 10. They all need to talk about when the forelimb is 0. Which of the following is a correct interpretation of the coefficient of determination? Okay, so I don't know if this went in my notes. Did I stick this in here? It comes up sometimes, so we might have to Google this, or here's a perfect example where we're gonna maybe add it to our chart here. So our coefficient of determination is our r squared. So that's another name for r squared, our coefficient of determination. All right, and r squared is 21.1. Okay, so we like these. And what are we going to interpret? Well, it's the variability of the, well, I'm going to let's look here in our notes. It's the variation in forelimb is explained by the linear relationship with hind limb. It's the variability in hind limb as it is explained by the linear relationship with the forelimb. So it says here, this is interesting how they ask this question, that this would be the variability in forelimb that's explained by the linear relationship with hind limb. I think I like that one better. This is an interesting one, so I'm just going to star that. That's interesting. Okay. I think my notes actually say the opposite, so I want to look that one up. Okay. The predicted forelimb length of a hominid with a hind limb of 600. So we said that forelimb is our x, and so they're saying y hat is 600. Your predicted hind limb is 600. Oh, no. It's saying it's saying these are the y hats. Which is the predicted forelimb when you have a hind limb. So they're saying when x is 600. So we're going to plug in 600 to our formula, right? And we were given the formula 436, you know, right here, 0.297. 0.297. All right, so we're just going to crunch these numbers. 200 times 0.297 plus 436. And I get an answer . oh, that's interesting. I'm getting an answer of approximately 800. So it's like maybe the answer key is off. Yeah. Let me crunch those one more time just to double check. 4360297. Oh, I see what I did wrong. I added it twice. Okay, you at home are probably seeing my math mistake here. Nice. Okay, so I get about 600, and that redeems my faith in humanity. I'm getting the same answer there. Good. What is 12? It says, which of the following would be false? This is a good model. The residual plot would show no distinct pattern. Okay, we're going to have to look back on that. The slope of the line and the correlation coefficient are both positive. That's true. Right? This number here is positive, and they have to be the same sign. The standard deviation indicates the scatter plot is curved. Wait a minute. Our standard deviation cannot indicate that something is curved. The standard deviation is just going to tell you how far a number is away from the mean. It's not going to tell you whether it's curved. We have to look at the scatter plot and the residual plot to determine the curve. So I've already found my answer that's false. All right, 13. Suppose the coefficient of determination, right? So that's our r squared. Between two variables, x and y, has a value equal to 1. So if r squared is 1, and we took the square root of both sides, that means r is 1, which means that the dots, and it's positive, which means the dots are exactly lined up in a positive way. The dots are exactly along that line. So which of the following would be not true? There has to be a strong relationship because the dots are right along there. Okay. Looking at our data here, it says the set of data has the following scatter plot. What is true? So as we look at the data, it says a line is not an appropriate model. So we notice here, it does seem to make a smile. So I like 1. So I like 1. So I don't like B and C. The least squared regression line has an intercept of 0. Okay, so what would be the least squared regression line? It would be something like that. It does not have an intercept of 0, so that's garbage. It has a slope of 0. Nope, it has a negative slope. So it looks like it's fall 1, maybe run 1, fall 2, run 3, something like that. So it's definitely got a slope, so I'm going to pick only 1 is true. Number 15, the correlation between x and y is 0.84. Okay, so that's our correlation. What is the correlation between these two values? Interesting. So I think I need a formula. This is a weird question. I haven't seen a question like this, so I don't think that these would show up on a test. I'm pulling this out of another book. Our answer, because you guys would be able to see the answer, is C. I'm going to try to answer this one, though. This is interesting. So let's looking on our formula sheet. Let's see if we can find an equation for R. Here's R. Yeah, no. So looking here, let's just go to our internet, right? Formula sheet, AP Stats, and I'll click images. Ugh, you're kidding me. Oh, here it is. I don't see a formula for it. Oh, yep, I see a formula for R there. I see a formula for R there. Yeah, I don't see this as a question. You know, I've been teaching this 6 years, and that's not a question, not a type of question I've answered before. So I'm just going to throw that question out. There you go. So that's chapter 3.